Higgs boson is this sort of renegade particle, kind of popped out of nowhere. The original paper that was written was just the Higgs mechanism, the whole theory. And then one person who reviewed the paper, another person who looked at the paper went, yeah, but you got this little particle here. That's a particle, that little piece. You can't sweep that under the rug, that's a particle. You better go find that particle. That became the Higgs particle, the Higgs boson.
The theory about the Higgs boson came in the mid-1960s, and so it's been talked about for a long time. And people have been looking for it probably since the late 1970s. The name the God particle is viewed by scientists as a very unfortunate one. It came about because a PR person wanted to give a catchy title to a book written by Leon Lederman, who's a Nobel laureate. They said, how about calling it the God particle? I think that'll sell. And so it became, at least in the title of the book, the God particle.
The Higgs mechanism is the simplest, most elegant that we know of way to patch things up so that it works.
It's very important to have found the Higgs boson because it fills in a real gap in our understanding of the way the world works. Without a Higgs boson, there really wouldn't be a universe at all.
One of the patterns that I've seen, anything that nature doesn't explicitly prohibit, you better go out and look for it.
The Large Hadron Collider is a particle accelerator. Protons are accelerated to nearly the speed of light. One set goes in one direction, the other set in another, and they collide head-on. And in those collisions, the energy allows you to create new particles. And we measure what happens when those collisions occur, and that's what enabled us to discover the Higgs boson.
The name of the game in particle physics is to study the phase changes in the early universe. And by early, I mean the first billionth of a second. What the detectors are doing is creating the universe in the first billionth of a second. That's what it's doing.
The CMS experiment is a collaboration of more than 2,000 scientists from more than 50 countries located literally throughout the world. We've been working together for more than 20 years. We participated in building a particular part of the detector, which is called the Hadron calorimeter, and it's a detector made up of large slabs of brass and plastic, and the plastic emits light when particles go through it. And that's how we make the detection of the particles in that particular part of our detector.
I worked on the electronics for a piece of the detector. We had engineers here and postdocs and myself, and we all designed the thing together.
So it's just one piece of this large detector, which is about the size of a 5-story building and has millions of channels of electronics and is located 100 yards underground, and we participated in building a piece of it. In addition, we've analyzed the data that came out of it and done physics analyses looking for new particles, measuring the properties of the top quark.
It's a privilege to be able to analyze the data that 2,000 or 3,000 people worked to get. There's 4 of us, professors, and students, postdocs, assorted other clerical technicians. A lot of people contribute.
What's your Eureka moment with the Higgs? When will you?
Oh, this is science. There's no Eureka moment,
Think of a picture where at first you only see a few dots and you don't know quite what it is, and then there are a few more dots and you can sort of make it out, and then as it gradually, more and more dots come in, you see exactly what it is.
I don't think there'll be a Eureka moment where we all hoist our beers and go, now we know everything. But I think there's a Eureka moment where we can say, I think we're seeing the Higgs.
The next thing for the University of Maryland team is we'll go back to work on the Hadron calorimeter to make it better so that for the next run, it performs even better than it did in this run.
I think it's pretty amazing that human beings could ask the question, what was the universe like? How old is the universe, and what was the nature of it back before atoms were formed? I think it's fascinating that human beings can ask this question and have the prayer of answering it.
It's a real triumph of all the people involved, showing that if you have a common goal, people really can work together and do these things.
And I like thinking about what human beings can do when they pull together.